Lemon water, because lemon has lots of vitamin C, and they think vitamin C is good. Vitamin C is good. Hello everyone, it's July the 12th. So I finally decided to try async IO in Python. It's a bit scary, right, at the beginning. Every time you go into concurrency, you got a little bit scared, but just read some articles. There are a couple good articles online I got from the realpython.com. I always like that website. And try out a few examples and just go ahead and do it. And once you do it, you realize, because initially I was thinking, okay, what if I forgot to write async as some function, forgot to write await as some function? Don't worry, the error message tells you. If you miss some, it tells you. So it's not that difficult to debug. And honestly, it's from the design itself, it's a much better way to handle I/O than threading, because this is called cooperative, right? It's a cooperative. It's a cooperative concurrency. No, it's another word. It's cooperative, because the threading is preemptive, right? Because it's preemptive because in threading you don't have control when a function gets switched. It's decided by the operating system. But async IO is cooperative. You decide. Yeah, every time you write await, that's when you're telling the event loop, okay, can just leave it here, let it run, I'll come back later. So anyway, I had a so far good experience with async IO, and I haven't finished rewriting the app yet. And there are a lot of parts need to be changed to async IO, but I think I can get it done and see a performance boost. That's what's important at the end of the day. Okay, so first things first, binary tree, level order traversal. Given root, I think I've done this more than twice. The level order traversal of nodes values from left to right, level by level. I see. All right, so let's not waste time on this. Let's just get it done so I can go to the other problem. I'm more interested in solving the other problem at the moment. And for this one, I'm just going to use BFS and call it a day. All right, so Q. Shouldn't we? Yeah, we should have a result. Should be right. Oh, oh wow, type error. Did they run? Did they run my pandas? Oh no, I think they're checking. All right, it's not right. Yeah, not this. And I don't even need to. Oh, I do actually. Huh. Like that. How about this? A few more lines. Oh, only once last time. Yeah, I don't want to keep on this one, so I would just move on. And I know how to solve it in DFS. You just keep track of the level and then append it to. All right. As I'm talking about it, let's just do it. It's fun. Always do it 2 ways, right? Okay. Oh wow. Huh. Why? Why is this one faster? Don't care. This is from yesterday. Okay. Alright, so back to this one. Now we have a wrong answer for this. Alright, it's understandable because I need to do something here. So I need a update, I need a query. I need a node. I need a range. Do I need a range to query? So the idea is when I query, right? And how would it still have a result? Yeah, I'm surprised there's a result because I said if they're the same, then there's a 21. Where does the 21 come from? Ah, we have this. Nope, we will set the count. Not here. And then it should be 0 or something. Yep. Now we need a query. So a query, let's say low and high. We shall fill it up. Okay, so the rule shall be you only fill it up if it amounts to something, right? If it's completely filled. Otherwise, I don't want to put a value in there. Or you can say like there's that many in this. But if it's that many in this, okay? If it's that many in this, then in the query, right? When a query low and a high, and we say if no matter what, you have the query, okay? So when I query, but if we cannot guarantee, because we add some, I'm thinking there should be two things. One is if the count update, right? If I update given this range, and then if it's inside, then we shall you know what? Let's think, right? Let's think. I give them a low and a high, and then a node has a low and high as well. Yeah, let me do this. If node low is smaller or equal to, and node high is larger, so the low and high is in between. Okay? If it's in between, then the count shall be high minus low plus 1. Then we're done. No. Because it can be landing multiple times. Hold on. So my idea is we only count it when it's completely filled. If we have something that's not completely filled, but then will lead to error. Because if this range is the original range, is inside the original range, oh, that's what now we go have. So we'll only fill if it's completely filled. Okay? We'll only fill if it's completely filled. Yeah, I see the value in this one. So we'll fill the value if it's completely filled. Otherwise, we don't fill it. But we will fill them eventually because we're going half, so we'll definitely split. All right, we'll split. We will fill something. And now we query. Right, now we query the entire range. Right, we query the entire range. And when we query the entire range, we can go really deep. Right? Because if it's 0 at the moment, it doesn't mean it's really 0. It just means, we can set the highest. So every time we query the largest value that we have encountered so far. Okay, so we can reduce some of the search. And then when we search in this, we have to search through all of them. That is a problem. Because I don't know if, we need a marker to see that it's partially filled or not filled. It's partially filled. Like if we hit something that has the count, then we know it's completely filled, right? And if it's a 0 and partial, false. Partially filled is false. And we can change it to true, but still don't do the count. So this no.count is this, and no.partial is equal to true. It's partially filled and this. Otherwise, mid is this. So no matter what we're hitting a node, then its partial is always true, right? We're hitting this node, and the partial is always true because we're hitting it. It's always partially filled, and now it's blah blah blah. Now, right? We say if node, if not node, I'll just return. Don't have to return anything. Now we have a node. We look at the partial. If the partial is false, if not node or not node.partial, we just don't go down that path. Otherwise, we say if actually we can return an int. Right? We say if no.count, that means it's completely. Then we just return no.count, right? Otherwise, now we are in a situation where the node has not see complete fill, but it does see partial fill. Okay, it does see partial fill. So now we're gonna go mid, right? We go mid equals this, and we can say, yeah, that should return 0, right? If something returns, right, as mid, then we go self.query node.left So we don't need, why do we need this? Right? We just query node. We just query the left node. Now we don't even need this. We just query the left node. And then we say left return, right return, self.query, node.right. So we query both, and then we say if and right. That means for somehow the left gets completely filled and the right gets completely filled. So when they return like that, then we say node.count equals left plus right. Right, and then we return node.count. And if any one, left or right, is not good, then we're just going to return 0. Right, so in this case, we're just going to return self.query self.root. Let's see if this one works. Huh, the hell? Oh yeah, of course. Ah, I see. Now these are the count. So we shall return this plus this. But we say if node.left, if node.left and node.left.count. Yeah, we always have to. We always have to, unless it's the leaf node. How do you handle the leaf node? Well, the leaf node, if it got hit, you will have the node.count have a value. If it doesn't have a value, and then we just, I mean, it's not hit. So we cannot put any value at it. Right, we just say if node.left and on the left-hand count and node.right and node.right.count. So in both children, so node.count shall equals node.left.count plus node.right.count. But the LR and RR is not necessarily the same. Okay. Now we try it. And now they pass. We have a couple of test cases. Come on, I want a test case. Try this one first. Okay, this one pass. How about, and this one shall pass. And of course, this in this, yeah, this is this one. 15 test cases. All right, let's see if we have luck in this one. Doesn't seem to be lucky. time limit. Oh, I don't need this. Oh, we passed 71. Not bad. So, need to be smarter. I don't know, what else can I do? I mean, the current solution was from what I thought about, during sleep. I was trying something new and then it worked, but it didn't work fast enough. How can we optimize? Well, what we can optimize is if we can have like this, because every time I query, I go from the start, and yeah, of course, every time we query, we go from the start. Or maybe we can, I don't know, every time we add, if we have not add anything and then we query, we can just return the previous query. So we don't have to go through the whole thing. You see what I mean? So we add, we do add, and then when we query, and so is last add false, right? And then self dot current count 0, right? Okay, so when we add, the self dot is last add equals true, and then when we count, we can say if not self dot is last add. So last time we have not added, then we just return self dot current count. Else we say self dot current count equals this. Also, if last, right, then we do this and now return this. How about this? It's like a hack, right? This feels like a hack. Didn't work. Did not work. I was actually trying to see, because I have a bunch of add, right? And then I have a bunch of count. And you just keep counting. So it shall work. It's just all these adds. So there's time is spent on the add. Gosh. What are the values used for the add? Like none of these count actually do anything, because I realized, lordy monstrosity, look at these things. So none of them are overlapping. Shoot. Yeah, it has to go really deep. I can see, like, this value will have to go, I don't know, to the log or something. It's definitely not on a call, because I set up this and then, oh, hold on. I forgot. I thought I got it. It shall be false. And then next time call, it will be false. We'll reset to false. Alright, show me. Come on. Come on. Come on. Like all the counts should fly by. Yes. Come on. Let's do this. Let's do this. Let's do this. Do this. We still got it here. So pass here, so it is faster. So this hack definitely works. But this, and the thing is, you have to, like, if you don't populate a tree, then another hack. So when these come in, right, and the new thing come in, I can just say, so if they don't overlap, and they must be somewhere else, and if they overlap, I put into the tree. If they don't overlap, okay. If they do not overlap, not overlap means that these things I can put into a set. Now if it's coming in, if the two values are not inside, okay, so another hack, okay, which is self dot none overlap, not overlap, a set, okay. So when you add, if left not in self dot not overlap, and right not in self dot not overlap. So if both are not, then that's a non-overlapping. So we can just count it. Say self.not-overlap dot add left self.not-overlap.add right and self.current count plus equal to right minus left plus 1. Else, if they are overlapping, we put into the tree. Okay? And then we do this. We run it. Holy crap. This is not right. How is this not right? So A13, so add it to it. Oh, 26. How do you know? Well, if we can keep the minimum and the maximum. We keep the minimum and the maximum, right? And then the new pair comes in. If the minimum is larger than the maximum, then we've like a new range is this. Okay, so a slightly different idea. But why would this come out as nothing? I expect to come out with something. Plus equal to. Yep, that's wrong, I know. So that's not right. We shall have the min and max. Hold on. Gotta do something very important. I'm hacking this problem. Can't solve it. I'm gonna use a bunch of hacks. Yeah.
I had a lot of playing with squeaky toy today.
You heard a squeaky, squeaky, squeaky?
Yeah, like.
And I similarly brought it to the company today. I can hear a squeak, squeak, squeak today on the company. I don't think it's a dog, it's just a toy. And then I saw a rubber duck. So I think that's probably what makes the noise.
Oh, you told them about the duck?
No, I think the squeaky thing in the company is a rubber duck.
Yeah, I'm saying you told them about the duck.
No, I don't tell anything to anybody. I don't talk to anybody. Alright, continue with the hack. Wait, did we? No, we didn't do the hack. I'm going to keep a min range. I'm going to keep a max range. Okay. Then we say if right is smaller than self dot min range, and self dot min range, self dot max range equals left and right. Actually, it's smaller equal to. What if it's equal to? You know what? We can handle this as long as it's not contained inside. So here's the max range. If it's hanging, so max range means, but it doesn't mean it has everything in it. So we can handle equal to. Max range just means, We're trying to say if there's no overlap, then we don't have to go through, but we have to upgrade the range. Yes, we have to upgrade the range. If we have overlap, and we don't know, which it could be 1, so if it's equal, we can handle if it's equal, right? Yeah, we can handle, like if it's the minimum range is here, then we go all the way here. So I think we can handle equal case. So we say, if right is equal to the main range, right, then self dot main range equal to left, and self dot count plus equal to right minus left minus 1, just minus left. We don't plus 1 because it's already counted. If right is smaller than self dot main range, well, it should be smaller equal to, and plus right is not equal to self dot main range. If right is equal to, I can just like put a parentheses. If right is not equal to, then we add a 1. If it's equal to, then we don't add a 1. So if right is smaller, if left is larger or equal to self dot max range, right? And then self dot max range, and then self. It's fine. If maximum of marvelous, wonderful, good stuff. Amazing and lucky.
I forgot that's attachment.
Oh yeah. It smells good. One billion, but it smells good. They just don't. Alright, continue with the hack. We say, do this if the left is larger than, then max range should be equal to right. Right? And then self.count plus equal to right minus left plus left not equal to self dot max range. Oh, we already changed the max range. Okay, we'll change it at the end. The left is largely equal to the max range. Main range should be main on this. And then if it's equal to, then we don't count. Otherwise, okay. So if elif, basically update the range, and then else, which means the right is larger than the min, and the left is smaller than the max. In that case, we're gonna have to update. Okay. And then count. Run it. Huh? A method? What? Oh, current count. Oh, and we update. I see. You still need to update, otherwise we're double counting. This is exactly what happens. We're double counting. Dang it. I don't know. I think I have to look into the hint. I'm gonna reverse this back to the last time we submitted. What? Hints. Binary search tree. Binary search tree. What if we hold all these overlaps? No, all these things. We hold all the non-overlaps, and whenever something comes that does overlap with them, then what do we do? We sorted it, right? When it does overlap, we sort and binary search. And we make modification. A new one comes in. I don't know, I have a new idea, but it's kind of late, so I don't want to try it today. I mean, we got to 71 test cases with this, but it's not enough. So my new idea is every time it comes, we're just gonna sort. No, we're gonna, if it's non-overlapping, we just keep append. We sort the thing, right? Because it's a pre-sorted, Python sorts very fast. So we will sort the whole thing. Actually, if we sort it once, yeah, we just sort the whole thing, and then if it's no overlapping, we'll keep pushing in. And when I say no overlapping, just means if it's towards end or towards the front. If it's in the middle, what if it's in the middle? What if it's in the middle? Make a binary search, and then we realize then we append to the end. You have to search every, you have to sort every time. No idea. I don't think it works. So yeah, I'm gonna check the solution. I don't know. Segment tree. How can segment tree be working? Merge intervals. Tree map. BST. Yeah, sorted list. I don't want to use sorted list. Do you have to keep it sorted? A map. Alright, I'm not gonna do it today. I'm gonna sit on it, mulling over it, and then give us something to do tomorrow. Man, one problem can get stuck for so many days. I kind of see the point. Yeah, you do have to, unfortunately, like sort for it. But I think that's just necessary. A necessary evil. Keep all these test cases. Yeah, segment tree is not working. It's close, but it's not working. Alright, I'm gonna end it today, and then we're gonna try that merging, whatever that merging thing, tomorrow. I mean, I think I was thinking like it's gonna cost a lot of time, but what might end up happening is we keep everything in a map where the left interval is the key, the right interval is the value, and then the new thing coming in, we always sort whatever we have, and then we can binary search. All right, so sorting is O and log n. Binary search is log in, and we can find where we need to be. And once we can also not do that, but that will make it faster. You think it's going to make it faster, or we can just sort and then go one by one. Wow, we can sort because it's dominated. Hold on, let me think. If we take everything out and sorted it, right? Then that's a list, and then we can binary search based on the left, okay? And then for each one, I check the value, check what I have, and then I can remove it, put myself in, and remove it. Okay, yep. I'm gonna try this tomorrow, not today. All right, I'll see you guys tomorrow. Adios.